All right, go to page 593. All right, page 593. Inscribed angles. Today, by the end of the class, we're going to be able to describe relationships between inscribed angles and use those relationships to solve problems. 593. Lesson 10-4. Then we're going to be able to identify relationships in inscribed polygons, because you can draw polygons inside of circles and then use those relationships to solve problems. So this is actually the very first day of this unit last week. I actually mentioned the idea of an inscribed angle, and that is if you have an angle whose vertex is on the circle and the other two parts of that angle are points on the circle that create two chords, basically, that gives you an inscribed angle. The technical definition is here. An inscribed angle has its vertex on a circle and sides that contain chords in the circle. In circle C, angle QRS is an inscribed angle. An intercepted arc, so first of all, it's made up of, the angle is where the vertex is on the circle, and the other 2 points of that angle are also on the circle, but they create chords here and here to make this angle here with vertex on. And then what we end up with is something called an intercepted arc. The intercepted arc is the arc that is intercepted by the sides of the angle. So if you have angle QRS inside of circle C, it creates an intercepted arc called QS. That's what we're dealing with. So an intercepted arc is just the two endpoints of that angle that basically cut off a portion of the circle and makes an arc. So this is the intercepted arc QS. That part lies between the two lines intersecting it. In circle C, minor arc QS is intercepted by angle QRS. There are 3 ways that an angle can be inscribed in a circle. 3 cases here. Case number 1. Here we go. Case number 1. Listen up. Center P is on the inscribed angle. That is a possibility, which means that one of the sides of the angle is the diameter. The second case is that the center is inside the inscribed angle, kind of like this first diagram up here. And then the third option is that center P is in the exterior of the inscribed, it's outside the angle. So it's either on the angle, the center is either on the angle, the center could be inside the angle, or the center could be outside the angle. Those are your 3 options. All right. There's a quick formula that we have to figure out the measure of an inscribed angle. And I did mention this last week at some point. If you don't remember, that's fine. So it says, first of all, for each of these cases, the following theorem holds true. And this theorem says, it's the inscribed angle theorem, and it says that if an angle is inscribed in a circle, listen up, guys. Eyes up here. If an angle is inscribed in a circle, so angle number 1, then the measure of the angle is equal to half of the measure of the intercepted arc. So basically, this angle here is equal to half of the degrees of arc AB, or the degrees in arc AB are twice the amount of degrees in angle 1. So if this is a 90-degree angle, then arc AB has a 120-degree measure. What? 90, sorry, 180, yeah. 90, 180. Yeah, sorry. Yeah. So if this was 60, AB would be 120. If this is 90, this one would be 1. This is probably closer to a 60-degree angle. Anyway, so if angle 1 was 60, arc AB would have a measure of 120. All right. So that's the mathematical relationship. It's a 2-to-1 relationship, so it is not super complicated to remember. Theorem 10A is the next thing that we're looking at here. It says if two inscribed angles of a circle intercept the same arc, or if they intercept congruent arcs, then the angles are congruent, which kind of makes sense, because if you have angle DCA and you have angle ABD, and both of those angles intercept arc AD, that means that both of those angles must be congruent to each other. Because this arc here would be twice the amount of degrees of this angle and twice the amount of degrees of that angle, which makes those angles the same. So that would be that theorem. We're calling that one 10.8. Any questions about that? Seems to make pretty good sense. Let's keep going. Let's do some math. So, first example here. Measure of arc CF is what we're trying to figure out. And arc CF is right here. It's equal to 2 times the measure of the inscribed angle. So, what angle are we talking about? Look for an angle that has endpoints at C and F. What angle are we dealing with?
Well, that one in the middle, no?
Yeah, it would be, because looks like that. So arc CF is the intercepted arc right here of angle CDF. So CDF has endpoints that intercept arc CF. So the measure of arc CF is going to equal 2 times the measure of angle CDF, which means it's going to be 2 times 40, which is what? 80. Yeah. Classic elementary school.
Oh, sorry.
Did your teachers do that to you in elementary school too? No? Mine
That's
did.
what they do to me in high school.
Do they? The English teachers though, right?
Mr. Companion.
Oh, okay. Oh,
I would lose the-
science, huh?
That's what they did to me.
All right. So that's our answer for example 1 there. So for part B, we're trying to figure out the measure of angle C. So the measure of angle C, I'm going to go ahead and do another highlight here. Angle C is right here. So the intercepted arc with angle C would be arc DE. We know the amount of degrees that arc DE is. So that means that angle C is half that. So this is going to be half the measure of arc DE, which is half of 98. So how many degrees is angle C? 49. There you go, 49 degrees. Questions about that before we look at some more? All right, let's keep going. So these first questions are all about figuring out some angles here. And then we are going to move on to some polygons within circles after this. So example 2. Figuring out the measure of inscribed angles. So this one here is going to be a little bit more challenging just because it looks like we're dealing with triangles, and we certainly could say that we're dealing with triangles. However, this arc here, BC, is being intercepted by angle BAC and angle BDC. And they're just calling those angles A and D, which is fine. So angle A, its sides end up intercepting arc BC. Angle D, its sides also intercept arc BC. So I'm just going to go ahead and highlight those two so you can see them. So if we're talking about angle A, the sides of angle A are like that. And then angle D, the sides of angle D look like that. They both intercept the exact same arc, which is arc BC. So if two angles intercept the same arc, what do we know about the angles? They're congruent, yeah. So angle A is congruent to angle D, which means the measure of angle A is equal to the measure of angle D, which means that 5x minus 12 equals what? 3x plus 2. Now, there's a little bit of algebra that has to happen to solve for x, so go ahead and solve for x real quick. You know what x equals once you have it. What number is x equal to? 7, yeah. Subtract 3x from both sides, get 2x over here. Add 12 to both sides, get 14 over here. Divide by 2, 14 divided by 2 is 7. So the measure of angle A is equal to 5 times 7 minus 12, which would be 35 minus 12, so 23 degrees. How could you verify that to make sure that A is 23 degrees? Yeah, plug it into the other one as well. 3 times 7 is what? 21. What's 21 plus 2? 23. They match. So if you're unsure about your answer, just plug your value of x into the one that's supposed to be congruent. If you end up with the same number, you're good. All right. I want you to do this one on your own. Find the measure of angle T.
The A and B, it's in then they still do.
So you're asking about what now? On this one? The angles are congruent, yeah. The angles, so the lengths of the chords, definitely not the same. But the angle openings at A and D are the same. Yeah. Yeah, we're talking about like chord length on Friday. We're going back to angles. Gotcha. So try this check step on your own. Solve for the measure of angle T. That is an answer, but it's not the measure of angle T. So before we answer this one, what does x equal? 20. X is 20. All right. So x equals 20. So we're gonna be writing, So we're gonna be writing, let's say 3x minus 5 equals 2x plus 15. And that is because angle T is congruent to angle U, because both T and U intersect arc SV, which means the angles have to be congruent. If you subtract, what's it up, guys? If you subtract 2x from both sides, you get x right here. If you add 5 to both sides, you get 20. X is 20. That does not mean the answer is A. That means that x is 20. The answer is D because you got to plug it back in. 3 times 20 is 60. 60 minus 5 is 55. If you want to verify, go over here. 2 times 20 is 40. 40 plus 15 is also 55. So the answer is D. X is 20. Angle T is 55 degrees. All right. Questions there? Let's keep going. Going to talk about this proof here real quick. I'm not going to give you a proof on your quiz or your assignment today, but your notes have a little bit of a proof. And it's only one thing that needs to be brought in here. So I'm actually going to have you tell me what we're actually using here on step number 4. So it says that arc QR is congruent to arc ST and that arc PQ is congruent to arc PT. The fact that those things are given, okay. It says that angle QPR is congruent to angle TPS, angle QRP is congruent to angle TSP. That's because if 2 inscribed angles of a circle intercept congruent arcs, then the angles are congruent, right? Let's see, where are those intersecting arcs that are congruent? So we're talking about angle QPR. So QPR is, okay, so they're intercepting congruent arcs, so those are congruent. Okay, so that means, let's mark those on our diagram because those are not marked on there. Angle QPR is congruent to angle TPS, and angle QRP right here is congruent to angle TSP, which is this one here. So we got some things marked. So it only shows us the given congruency markings. So then we're going to have to say, so then QR is congruent to ST. And it says that congruent arcs have congruent chords, which we learned last week. So then I'm just going to do 3 here, 1, 2, 3 there, and then 1, 2, 3 right there on the actual triangles. So in our triangles, looks like we have 2 pairs of congruent angles, and we have 1 pair of congruent sides. So what is our congruency statement here? What's our reason for these 2 triangles being congruent based on what we just marked up in those triangles? Angle, angle, side. Yeah, angle, angle, side. Good. 2 angles and a side. The side is not in between the 2 angles, so it's the non-included side with 2 angles. Nice. Angle is only for similarity. It's not for congruence. Yeah, because if you have all 3 angles congruent between 2 triangles, they could be different sizes. Doesn't prove that they're congruent necessarily. We could have used angle side angle though, because arc PQ and arc PT being congruent also means that chord PQ and chord PT are congruent. So we could have said angle side angle for that one. Or actually, no, that would have been angle angle side as well. So never mind. Yeah. All right. So let's move on. Let's talk about inscribed polygons. Inscribed polygons means, so here we go. If you have an inscribed polygon, that means all of the vertices, all the corners of the polygon lie on the circle. Inscribed triangles and quadrilaterals have special properties. So we're talking specifically about inscribed triangles and inscribed quadrilaterals, which is good because we've already done units on both of those things, so we know about them. So if you have an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. So it makes a right triangle. And the reason for that, go ahead and talk about this for a second. If you have a diameter and you can make a triangle with that diameter, it means that this angle is a right angle. Why is that? It has to do with intercepted arcs and inscribed angles.
Because that goes right through the diameter,
Okay.
making it a semicircle.
Yeah. So here's our arc, and then
And the arc would be 108,
yeah,
and then that, and then half of that would be like.
exactly. And then we're talking about an inscribed angle. The intercepted arc is always twice the degrees of the inscribed angle. So if you have a diameter is exactly half of a circle. So the arc that it creates with a diameter is 180 degrees, which means that the angle that you go back to, if it's inscribed, it has to be half of that, so 90. So anytime you have a triangle inscribed in a circle, if one of the side lengths is a diameter, you automatically have a right triangle. FJH is a 180-degree arc. Oh. Oh, FDH. Oh, good question. So if we were to draw, I think I understand your question now. So if you were to draw a triangle that used the same diameter, and then you went to here, would that also be a right triangle? Yes. Yep. J would be 90 degrees if you did it that way, for sure. All right. So that's a little bit of knowledge about triangles inscribed in circles. Now quadrilaterals inscribed in circles. Well, there are many different types of triangles, including right triangles, can be inscribed in a circle. Only certain quadrilaterals can be inscribed. So you can do right triangles, you can do all kinds of triangles inscribed, but only certain types of quadrilaterals can be inscribed, and here we are. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. That's interesting. So that means that the sum of angle M and angle K would have to be 180, and the sum of angle L and angle N would also have to be 180. So it doesn't mean it's going to be parallelogram or rectangle or anything like that, but it does mean that the opposite angles are going to be supplementary. I'm trying to think of, oh yeah, that makes sense. So, well, not really. Let me think. Let me think of a reason for that. I'd like to see a proof of that. That'd be interesting. So let's keep going. But we do know this as a fact. Opposite angles in an inscribed quadrilateral are supplementary. All right. So starting off with some triangles here. KLM is a right triangle because angle L intercepts a semicircle. So that means that angle L itself is 90 degrees. And we are trying to figure out the measure of angle K. So angle L has to be 90, which means that these two angles have to add up to what? 90, yeah, because if this one is 90, then the remaining two also have to add up to 90. So angle K and angle M would be complementary. So that would be, they add up to equal 90, which again adds up to equal 90. So if we combine like terms, what number do we have in front of X? 13x, good. And then minus what? Minus 14 equals 90. Right here, add 14 to both sides. So 90 plus 14 is 104. That would be 8. I think so. All right. So 8. 5 times 8 is 40. 40 minus 4 is what? $36. Okay. Now, an easy way to prove this would be to figure out the measure of angle M as well. 8 times 8 is 64. 64 minus 10 is 54. Does 54 plus 36 add up to 90? Yeah, cool. So easy way to verify that we solved this correctly. All right, solve for angle V. Do that one on your own. And by the way, U is the right angle here. Pretty quick lesson. So windy today. Yeah. I think you divided it by 11 instead of 9. Yeah. What does X equal? Let's start with that. 11, good. So we got 7x minus 5 plus 2x minus 4 equals 90. So those angles do not equal each other. That's important. They're complementary, so they add up to 90. 7 plus 2 is 9. Negative 5 minus 4 is negative 9. So that'll be 9x minus 9 equals 90. Lots of 9s here. Even more 9s on the next one when we add 9 to both sides. 9x equals 99. Divide by 9, x equals 11. Because we're adding these two together to equal 90. They're not equal to each other. Okay. Yeah, it's going to be a matter of remembering what we're dealing with here to, remember that those are not necessarily equal to each other, but they do always add up to equal 90 if the other half of the triangle is taken up by one angle, which it is. All right. So divide by 9, x equals 11. And then the measure of angle V, which is this one here, will be 2 times 11, which is 22, minus 4, which is 100 degrees is angle V. 18. Good. And we can verify that. 7 times 11 is 77. 77 minus 5 is 72. 72 plus 18, 90. That all checks out. Are there any questions about this before we look at some quadrilaterals and then call it a school year in terms of lessons? Cool. Turn the page. This is your last page of notes for the whole school year. Isn't that sad?
It's not sad.
That's sad. Probably not a sad feeling at all, which is fine. Let's see. Find some angle measures here. Stained glass. All right, we got a stained glass ornament. Luca is creating a collection of stained glass ornaments. The ornament shown uses a quadrilateral inscribed in a circle. Find the measures of angles F and G. So we are talking about that yellowish, orangish quadrilateral that is not a triangle. We know that opposite angles in a quadrilateral that are inscribed in a circle have what relationship? They're supplementary, yeah. Maybe, but maybe no, it's not a rhombus. No, it looks more like a trapezoid, if anything.
That's what I meant.
Okay. It might be a trapezoid. I don't know. We're not going to be able to prove that. What we are going to be able to do, though, is figure out some angle measurements here. Opposite angles of an inscribed quadrilateral in a circle are supplementary, which means that angle E and angle G add up to equal 180, and angle D and angle F add up to equal 180. So if we're trying to figure out the measures of angles F and G, we cannot set any relationship between those two because those are not opposite angles, those are consecutive. So we're going to have to do two separate equations, which is what it's going to show you down here, that are both equations that show that the angles are supplementary. So the first one it's doing is D and F. So angle D here, angle F here. Those are supplementary, means they add up to 180 degrees. So measure of angle D, 5y plus 16, plus the measure of angle X, 3y plus 4. Measure of angle F, not S. Would be plus 20, yeah. So 8y plus 20 equals 180. Subtract 20, 8y equals what?
Oh, wait.
Subtract 160. Divide by 8. Y equals? It is 20. Yeah, so usually if there's something like that, if there's a 0 and I know the number is divisible, I'll just cover up that 0 and say, all right, 16 divided by 8 is 2, add back the 0, so it's 20. All right, 3 times 20 is 60, 60 plus 4 is 64. So the measure of angle F is 64 degrees. Now, it's also good to make sure that the measure of angle D will be supplementary to that. So if we head back here, we say 5 times 20 is 100. 100 plus 16 is 116. 116 plus 64 is 180. So we're good. And then for the measure of angle G, add those opposite angles together. G is opposite E. So G plus E equals 180. X minus 4 plus 3x minus 16 equals 180. Combine like terms, what do we get? What's the next step here? 4x minus 20. Good. X plus 3x is 4x, -4 and -16 is -20. This time we'll add 20 to both sides. So that'll be 4x equals 200. And 200 divided by 4? 50. All right. So that means that the measure of angle G is 50 minus 4, or 46 degrees. So if we plug back in here, we should end up getting 134 degrees. Let's see, 50 times 3 is 150. 150 minus 16 is 134, which adds with 46 to be 180. So it all checks out. All right, last one from your notes. Here we go. Jewelry. I want you to figure out the measure of angle J and the measure of angle K. Opposite angles are supplementary. Keep that in mind. If you need to use some extra space, there's this whole margin on the left. So take a few minutes on that. I'll give you, let's go with like 3 minutes. See if you can do both parts of this in the next 3 minutes. Well, I take attendance because I forgot to do that. Wasn't planning on it. Yeah. All right, so for angle J, solving for x, we should have x equals 15. And then if we multiply 15 times 5, what does that equal? Plus 2. There you go. So measure of angle J, 77 degrees. Measure of angle K, we're going to set the other two diagonals, add them together, set them equal to 180, solve for y. Y should equal 7. 11 times 7 is 77. 77 plus 13 is 90. 77 and 90 for J and K. Questions about that? Cool. All right. So your final like regular assignment, you'll have one tomorrow, but it'll be a review. We're gonna do 1 through 9 odds. And so 13 through 31 odds. Skipping all the proofs. And let's see. Oh, 37 for sure. That'll be easy. And 39. So 37 and 39 will be the last two. All right. There we go. 1 through 9 odds, 13 to 31 odds, 37, 39.